Alright, so number 5. Are You Ready strikes a puck with a slap shot, giving it an initial velocity of 20 meters per second. The ice has just been cleaned, so it only slows down at a rate of 1 meter per second squared as it travels to the net 30 meters away. Ima Reston is standing down by the net, leaning on his hockey stick off to the side, a horizontal distance of 5 meters away. What must be Ima's acceleration if he's just to reach the net at the same time as the puck? So what are the two parts? The puck and Ima Reston. So the puck is given an initial velocity of 20 meters per second, and then it slows down at a rate of negative 1 meter per second squared, and it's traveling 30 meters. Ima Reston is resting, so his VI is 0. He's 5 meters away from the net, so that's his delta D, and we want to know his acceleration. We don't know the time it's going to take the puck to get to the net, but whatever time that is, that's the time that Ima Reston has to get to the net as well. So if we can find the time, then we can get Ima's A. So find the time for the puck. Now you might want to use the delta D is equal to VI delta T plus 1/2 A delta T squared equation. But if you do, you're going to end up with a quadratic because the VI isn't 0 here. So I would suggest that you might want to find VF first. So do VF squared is equal to VI squared plus 2A delta D. So VF squared is equal to 20 meters per second squared plus 2 times negative 1 meters per second squared times 30 meters. So VF squared is equal to 400 meters squared per second squared minus 60 meters squared per second squared. So VF squared is equal to 340 meters squared per second squared, which is 18.4391 when you take the square root. 18.4391 meters per second. Okay? Once you have that, then you can do, still for the puck, A is equal to VF minus VI over delta T. So delta T will be equal to VF minus VI over A. So delta T is equal to 18.4391 meters per second minus 20 meters per second over negative 1 meter per second squared. And you will get a time of 1.5609 seconds. And now when you have that, you can come up here and find the A. So delta D is equal to VI delta T plus 1/2 A delta T squared for Ima. The VI is 0. You're looking for A, so multiply both sides by 2 and divide by T squared. So 2 times 5 meters divided by that 1.5609 seconds, and that gets squared. And when you do that, you should get an acceleration of 4.1045, I think, if I could see, meters per second squared. Final answer. Okay? All right. Number 6, a math textbook is dropped from the roof of a school, passes by a window sometime later. The window is 1.4 meters in height, takes 0.2 seconds to go by the window. How high? So what are the two parts? They are above the window and the window. So a math textbook is dropped. So that means the VI for above the window is 0. Means the A is going to be 9.81 meters per second squared because it's free falling. It passes a window sometime later. The window is 1.4 meters in height, so that's the delta D of the window, and it's also going down. The A is also going to be 9.81 meters per second squared down. And it says it takes 0.2 seconds to go by the window. So delta T is 0.2 seconds. Okay, so then you get your given setup and then you say what's connecting the two parts. Well, what's connecting the two parts is that the VF of above the window as it's falling, we don't know it, but it's the VI of the window. Okay, so if we find one of them, we know the other. And the question wants to know how high above the window is the roof of the building. So you're looking for this delta D. Two unknowns in above the window, so don't start there. Start with the window piece. Okay, so window. What do we know? We want VI, we know delta D, A, and delta T. So delta D is equal to VI delta T, 1/2 A delta T squared, and you're looking for VI, so subtract the 1/2 A delta T squared, and then divide by the T. So VI is going to equal delta D minus 1/2 A delta T squared over delta T. Do I have to worry about negatives? No, because everything is going down. So what's the delta D here? 1.4 meters minus 1/2, 9.81 meters per second squared. The time, 0.2 seconds squared over 0.2 seconds. And when you do this, you get a VI for the window part to be 6.019 meters per second. And that becomes the VF above the window. So now we can go to above. We have the VF. We want the delta D. So VF squared is equal to VI squared plus 2A delta D. VI is 0. Delta D then is equal to VF squared over 2A. So that's 6.019 meters per second that you have in your calculator. Square it and divide it by 2 times 9.81 meters per second squared. Remember, if you're going to type that in your calculator, there has to be brackets around this part. And when you do this, you should get a D of 1.8465 meters. Okay, so that's number 5 and number 6. I'll do a separate video for 7 and 8.